All right, so one of the ones I wanted to do is let's do um, let's do magnesium oxide. Okay, so magnesium, and we'll just do the crossover technique here. Is group 2, so 2A, of course, so it's plus 2, and oxygen, of course, is minus 2, right? Because it's in group 6, so this is going to be a minus 2. All right, so when you do the crossover technique, this is something really important that I have to show you. It comes down like this, so it's, Mg, and so this 2 goes here, and then for the oxygen, this 2 goes here. All right, so this, of course, becomes, it's magnesium oxide, so Mg, so there's a 2 here, and there is a 2 here. Now, that is something that needs our attention. Whenever you have an ionic compound, okay, so this is clearly ionic, right? We have a metal and we have a non-metal. Okay, so that's an ionic compound. If you have like this situation where the subscripts are not in the least common, they're not like the least common factor. What we have to do only with ionic compounds, okay, this is only true with ionic compounds, you have to reduce this to the least common factor. So this becomes, so if you look at it, right, 2 goes into itself once, 2 goes into itself once, so this becomes MgO. So that is magnesium oxide. So this is the chemical formula for magnesium oxide. So that's how you reduce it. You write it like that. You always reduce it to the least common factor. All right, and from now on we're going to do that. I mean, this is the first time we've encountered something like that. They're not always like this. Sometimes there's going to be a 4. Not for magnesium, but for some of the transition metals, there'll be like a 4 here, and then a 2 here, and so we would reduce it to, whatever the metal is, and then be subscript 2, and then oxygen would be a 1, for example, because 2 goes into 4 twice. Let's just we'll just do some examples, and we'll see that. We don't have to try to imagine it. All right, so I'm going to go back to the oops, not that, to the PowerPoint presentation, and oops, here we go. So this is showing some other ways. Oops, not that. This is this just, there's nothing surprising here. This is all this table 9.1 is all from, you can get this information from the periodic table. The fact that, oxygen is -2, sulfur is -2, hydrogen can be +1 or -1, the halogens are all -1, and so forth. All right, so that comes from the periodic table. So here we have table 9.2, as I was telling you before, which includes the transition metals. So, for example, manganese is a transition metal. It can be +2, +4, or +7, and you don't know necessarily which one it's going to be ahead of time. So we're going to, and for example, there's lead can be +2 or +4. Mercury can be +1 or +2. But remember, these ones up here, even though they're transition metals, they're the exception. These 4, zinc, tungsten, silver, and cadmium, are only charged singly. I guess I shouldn't say singly. They're only charged one way. So zinc is always +2. There's no such thing as zinc 1, for example, or a zinc 3. It just doesn't work like that. But there is a chromium 2, a chromium 3, or a chromium 6. And in fact, when we name the transition metals, when we do ionic compounds with transition metals, we actually have to include the charge, the ionization, if you will. So, for example, there'll be either iron 2 or iron 3. All right, so let's take a quick look at an example at examples like that. All right, so let's stick with iron because that's kind of a good way to look at it. I mean, we could use any one of them, but oh, here I got to get more room. All right, so we have a nice clean slate. So I was just saying, suppose we had. Now we're going to introduce the transition metals. Okay, so suppose we had iron. There's the chemical symbol for iron. So iron can be iron 3 or iron 2. Let's start with iron 2. So it's going to be +2. And let's go with oxygen, for example. So oxygen's -2. And so we do the crossover technique, and so we get Fe2O2. And of course we have to reduce that to the least common factor. So this becomes FeO. But now here's how you write that, okay? So it would be iron, and then you put parentheses, and you use Roman numerals for what the charge of the iron is, okay? So this is iron 2, so there's the Roman numeral. You could write it like this as well. So that's the Roman numeral 2, so iron 2 oxide. Notice we haven't forgotten the IDE, right? The suffix IDE, because oxygen is obviously on the periodic table. All right, let's do another example real quick. Suppose we had iron. So I'm going to actually start this time. I'm going to start with the proper name, iron. So now it's going to be iron 3. Okay, so the Roman numeral 3. Iron 3 oxide. All right, iron 3 oxide. So, well, we can work this out using the crossover technique. So this would be Fe +3 this time, and there's the oxygen, of course, is already -2. It's always -2. The thing about this is, and I should mention this, the non-metal never ever leads you astray. It always does the same thing, okay? So that's a good thing to know about nonmetals, especially when we're trying to go either from the proper name to the formula. Oh, well, that's not the formula, but we're about to get the formula. So using the crossover technique, here's the formula. So it's Fe, and we're going to use the 2, right? So Fe2O3. So this formula, Fe2O3, is the compound iron 3 oxide. Okay, they mean the same thing. So whether it's this as the chemical formula or the proper name, iron 3 oxide. All right, so that's kind of nice. Here, let's do another one. I gotta look at this thing to give us some inspiration. All right, so. All right, so let's do one with these exceptions. One of these 4 exceptions. So let's say we had let's do tungsten. How about tungsten and I don't know, and sulfur. So tungsten is always +6, and sulfur is always -2. And so here we go. This is going to be tungsten sulfide. All right. So it's W. We're using the crossover technique, and it's going to be a subscript 2, right? Because we're using the crossover, and then S, and then the 6, the subscript 6. Right, so there's the crossover technique, and so what does this become? Now notice, remember, we have to, because this is an ionic compound, we have to reduce these subscripts to the least common factor. So 2 goes into itself once, right? So this is W, right? You don't write the 1, it's just implied. And then this 2 goes into 6 3 times. So this would be called tungsten sulfide. IDE. So, and notice, even though this is a transition metal, here, let's go back to our list. We do not use a Roman numeral. Okay, so these 4 are. Let's get back to it. These 4 are the exception. These 4, right here. Okay, so like I said, there's no such thing as tungsten 5 or tungsten 4, so you don't need to include the Roman numeral. All right, let's do another one. How about so lead? Let's do lead. You find a lot of compounds with lead. So lead is lead 2 or lead 4. So let's do an example with lead. Let's see. How about lead 2? Oh, well, I need a little room. So let's say we had lead 4, right? And so 4 would be IV. So lead 4. You can write, that's a perfectly good way of writing the Roman numeral 4. You could write it like that, or you could put the, do it like that as well. Lead 4. I don't know. How about carbide? Okay, so carbide. So it's lead 4 is joining with carbon. Okay, so we have Pb. That's this chemical symbol for lead is +4, and carbon is of course -4. And so you do the crossover technique, and you get Pb4, C4, and of course we're going to reduce this to the least common factor, and so that's going to be PbC. So that would be lead 4 carbide. Let's do right next to it. How about lead? Just to show you how different these can look. Lead 2. Remember, we have to put the Roman numeral in parentheses. Lead 2 carbide. All right, and so lead 2 would be, Pb. Where's my P? There's the P. Pb +2, and the carbon is of course always the same. It's always -4, and so we do the crossover technique, and we get Pb4, right? Because that comes from the carbon, the charge of the carbon, and then C subscript 2. And so we have to reduce this, right, because it's ionic. It's a metal and a non-metal. We reduce it to the least common factor, so 2 goes into 4 twice, so it becomes Pb2, and then 2 goes into itself once, Pb2C. So that chemical formula, Pb2C, is lead 2 carbide. Okay, so that's a good way to do that. All right, let's add, let's see, do I have time? I'll do it in the next video. The next video, just to let you know what we're gonna do. So if you go beyond this, this table 9.2, there's a table 9.3, and so table 9.3 has just let me introduce this, different what are called polyatomic ions, and most of them are negative, so most of them are acting like our nonmetals, with the exception of ammonia. Ammonium. Ammonium is NH4 and it's charged +1, so that actually acts like a metal. All these other ones, notice they're all negatively charged, different charges, and we're going to treat them the same way as we treat the nonmetals, or if we're talking about ammonium, we treat it as a metal. All right, so we'll do that in the next video.